And we'll go ahead and begin. All right. Hope you all had a good weekend. We got a short week this week because of Thanksgiving. So, and actually along those lines, I will not be here next week. I've got work obligations next week, so I'll be out. But they'll get some wonderful person up here instead of me, and then I'll be back the week after that. So, just don't be surprised if you don't see my face up here next week. I will be back. Let's see. I think the next assignment's already been posted, so you can get started on that. We might have a little chat about that later on if you have any questions. Otherwise, I think I'm ready to just start diving into reviews. Anybody have any questions before we get started? Let's talk about inheritance then, which was the topic for today. I like talking about things in forms of the relationships that we use to describe them. So the first question on our review is, what relationship do we use to describe inheritance? And this is the similar question that I talked to you about last week with objects. What's the relationship between an object and its instance variables, its fields? What do we say? Has a. Yeah, that's right. Yeah. And then we didn't talk about this so much last week, but there's a relationship between an object and its methods as well. Has anybody picked up on that yet? What part of speech would you typically use to describe what a method is? Is it I'm sorry? Belongs? Belongs, I think, is a general term that we can use for everything in a class, yeah? So applicable, yes, but not specifically towards methods. I'm sorry? Does? Yeah, so it implies some sort of action, right? Works with. Your methods really should be actions, they should be behaviors. That's words we've kind of used to describe them. They are verbs, right? If you cannot think of a name for your method that is a verb, an action, maybe it's not a method that you're talking about. Maybe you're talking about a variable. Maybe you're talking about something else. So we say that classes can do the things specified by their methods. So that might be the relationship, right? I can do these things. I can perform these actions. And so now we're on the topic of inheritance. What is the relationship that we use to describe inheritance? Is a. Yeah, that's right. So tiger is a cat. I think the examples used cats in the book, if I remember correctly. So we use is a to describe an inheritance relationship. And those are important things that I am constantly repeating in my head whenever I'm designing a new program, whenever I'm talking about new classes. So when we use inheritance, we're actually saying that something is the same thing as something else. And what powers does that grant us? What properties do we get by using inheritance? What does that allow us to do? I'm sorry? Organization is a big part of it, yeah. Superpowers, oh, I like that, yeah. Yes, superpower. So describes the relationship of, you see it here, I've referred to it as the base class, or you might call it the super class, or you might hear it referred to as, there's a third one, base class, super class, the parent class, right? All terms to mean the same thing, the class that I am inheriting from, right? And then the class that's doing the inheriting, we'd call that the subclass or the child class, right? Or you might hear it called the derived class, right? All terms used to indicate that a class is inheriting from some other base class, from some other superclass. What exactly are we inheriting? What am I taking from that base class? If I'm a subclass, what am I grabbing from the superclass when I inherit from it? I'm sorry? It depends? It does. What does it depend on? I'm sorry? What I wanted to take? What would I look at to know what I'm going to get? The constructor. So the constructor might tell me some information, yeah? You see, I've got access modifiers on my to-do list to talk to you about. So what am I talking about when I say access modifiers? Public and private. There's actually a third one now. package specific, or actually, I guess there's 4 if we count that one. Package, and then there's another one as well that also starts with a P. Protected, that's right, protected. Yeah. That's very sad. Protected. So I think public and private are pretty straightforward to understand, although what does it mean in this context for something to be public or private? If it's public, do I get to inherit that? Yes. If it's private, do I get to inherit that? No. Absolutely not. So then we have these 2 new ones, the package the package one and the protected one, which I got to be honest with you, the amount of times I've used a package level access modifier can probably count on 0 hands. I mean, it's not particularly common. I don't want to say you'll never use it because, you know, it's a big wide world out there, but not super common. Protected, however, yes, very frequently used, very commonly used. So what does it mean for something to be marked as protected? Or maybe a different way of thinking about this is, why do we need it? We've got public, we've got private. Doesn't that cover all bases? Why does protected even exist? Couldn't I just mark everything as public or private and call it a day? Yeah. Mm-hmm. Yeah, exactly. Yeah. Protected is kind of in between public and private. It allows things like inheritance to use those items, those values, excuse me. So I can still inherit those things, but they're basically private to anything outside of that inheritance chain, right? And as programmers, and actually if you're security minded, which we all kind of have to be, right? If you're security minded, the good rule of thumb is keep it as less exposed as you possibly can. So if private is too restricted, all right, I'll bump it up to protected. I don't necessarily want to make it public because that's opening it up to the whole world, to everybody. But let's bump it up to protected. That exposes it a little bit more, but still keeps it private to anything that's not inheritance related. Do these modifiers, so these modifiers, we've seen them applied to fields and methods, right? Am I inheriting both fields and methods? If I use inheritance, do I get both the fields and the methods? Or is it just the fields or just the methods? What do I get? So what am I inheriting exactly? We just talked about access modifiers to indicate, you know, whether I can inherit something or not. Now I want to know exactly what it is that I'm inheriting. Am I inheriting the fields? Do I get the fields if I say extends? Do I get all those fields? I do, actually. All the fields that are not marked private, I get. Anything that's marked public or protected, that's going to get passed along via inheritance. What about the methods? Do I get those? Yes, absolutely. Anything that's marked public or protected as a method is going to get passed along via inheritance. So it's all of it, all the fields and all the methods, as long as they are not marked private. Okay? Does that make sense to everybody? All right, constructors. So now think about the role of a constructor with inheritance. Constructor has one job. What's the constructor's job? To construct. Sure. Can we be a little more specific? You're not wrong. Can we be a little more specific? Assign values to fields. That is the one job of a constructor. So now with inheritance involved, right, we have to remember that, yes, we are assigning a value to all of the fields. Some of those fields might be coming from my parent class, my base class, my superclass. I'm getting tired of saying all those 3 names. Coming from wherever I'm inheriting from, right? I am still responsible for those. It is still my obligation, still my duty to make sure that those also get values. The good news is that I can leverage existing code for this. So the constructor from the base class still exists, and I can use it. How do I use the constructor from the base class? What word do I see? Super. Yeah, I use super. That's right. In fact, super has other meanings, other uses besides this one, although this is a very common usage of the word super. Anytime you see the word super in code, anytime you see that word show up, it's referring to base class. Your brain should just automatically think, all right, I'm grabbing something from my base class. You'll very commonly see that with constructors, and so then a common thing that you'll see, and we'll actually see this when we do some coding examples in a little bit, is that in a constructor I'll call super, and that'll take care of the fields from the base class, and then all I have to do then is take care of any additional fields that I may have created in my subclass. All right, great. What does it mean to override a method? We've actually already done this before. We've already overridden methods. What methods have we overridden? I heard somebody say something that sounded... toString, yeah, we've overridden toString and equals. Yep, that's right. So what does it mean then to override those methods? So there's something already there, but we don't want to use that. We want to use our own version, right? So we override that method and we give our own version of that method. So you can kind of see how this might happen with inheritance. Maybe I inherit a method from the base class, but that method is not sufficient for what I want my subclass to do. I can override that method and provide my own implementation of that method inside of the subclass. That's a very common thing to do. I don't have to do that though. I can use the method just as it was inherited to me. If it works, that's okay. I can override it if I want to. We just said that we have overridden toString and equals, which implies that there was already a toString and an equals method that we were overriding. So where did those come from? Java library, that's right. Anybody know any more specifics about that? Something that I'm sure you've heard me say before, and I'll say it again, it probably won't be the last time either. Everything in Java is an object. That means quite literally everything in Java is an object. And now that we have the proper tools to talk about that statement, right, what are we really saying? We're really saying everything in Java inherits from the object class. There is an object class. You can think of it as the birthplace of all Java objects, right? All Java objects come out of the Java object class. That object class contains a toString method and an equals method. Most of the time, though, we don't want to use those. I want to use my own toString and my own equals method, so we'll override those methods and provide more appropriate functionality for them. We don't see that inheritance, right? There's nothing in our code that indicates that it's inheriting from the object class, so that's a little bit implied in that sense. The inheritance that we're about to do in our examples, that we're about to code up, is much more explicit. We're actually going to see a clear indication that inheritance is happening. This inheritance that I'm talking about with the object class, though, is kind of hidden away a little bit, but it is there, and it is important to understand that that is actually happening. All right, last but certainly not least, what is actually I think I have more after this. What is an abstract class? Yeah.
A class that's empty, so you use it for your method.
Class that's empty. So you're on the right track. I don't know that I entirely agree with the term empty. I can't instantiate it. That's right. I cannot instantiate it. So I cannot create an instance of an abstract class. So then what's the point? Why would I create an abstract class? Inheritance. The whole reason for creating abstract classes is for inheritance. What does that gain us, though, right? It seems like more work. Oh, I have to create this abstract class so that I can inherit from it. What's the benefit for me to do that? Yeah.
If there are things you want to share with fields or methods,
Mm-hmm.
then it lets you do that once and have them shielded.
Exactly, yeah, exactly. I can share code. I can reuse code. I can write that code once in my abstract class, and that code will get reused across all classes that inherit from that abstract class. So, so yes, it's a very powerful tool. In fact, that's what we just described is actually just a reason to use inheritance in general. Code reuse is one of the big reasons cited to use inheritance, whether you're talking about abstract classes or not. Inheritance allows you to reuse existing code, which is going to make your life easier. It's going to make design easier. So if you're using inheritance, you should be asking yourself whether the base class should be abstract or not. Do I actually need to create an instance of this class? The word abstract is there for a reason, right? Abstract implying that it's not something that physically exists, it's just kind of floating around in the ether, right? So do I actually need to create a physical representation of this class, or am I just using it as a container to distribute things via inheritance? That's the distinction that we're making. And this is something that you'll see. This is a pretty common technique that will come up. All right, a couple more things to talk about. Polymorphism, very important concept. Very long, potentially confusing sounding word for a very important concept. What is polymorphism? Multiple different forms. Yeah, I mean, it sounds like you kind of broke that word down into its what is it? Probably Latin or Greek roots. I'm not an etymologist. I don't know for certain, but that's exactly what it is, right? So what does that mean in terms of programming? In terms of coding? If I have an object, let's say I have a tiger, right? We said earlier that a tiger is a cat. The act of polymorphism says, all right, I can treat that like a tiger, or I can treat that like a cat, right? I can treat it as any of the classes that it is. So if I'm using inheritance, if I have classes inheriting from other classes, I now have the ability to refer to things in multiple ways. I can refer to them as the subclass or as the base class, if it's convenient for me to do so. And actually, you'll see inheritance change the chains that aren't just two things. They might go farther, right? Maybe I've got more inheritance. I can refer to classes as anything along that chain if it's convenient for me to do so. And sometimes it might be. Sometimes it might be convenient for me to do so. We'll actually see an example of that in a little bit when we do a programming exercise. It's a very, very, very powerful technique. One that feels a little unnatural at first, but you'll hopefully see and understand the benefits of after you get a little practice with it. Are there any questions about that for now? Then the last thing for us to chat about before we do some exercises are class diagrams. So the pieces of a class diagram. I've got these boxes, right? What goes in the boxes on my UML class diagrams? What am I going to find in there? Name, fields, and methods. And then I have indications of the access modifiers of those as well, right? So it's just a very standardized way of describing classes. And then what else do I have on my diagram? Let's say I make a few classes, then what am I going to do? I'm going to link them up, right? How do I link them up? What are some of the things that we use? Arrows. What does an arrow represent? Inheritance. And then we also have just plain lines. What is just a plain line with no arrow on it represent? Pretty sure this was in there. I think that's just a regular old HASA, right? This object is contained within that one. And then there's an arrow that uses a diamond, which indicates that there are lots of them. So if I have a list of something, right, that would be an aggregate, an arrow with a diamond. So actually, that's what we're going to do next. We're going to make a class diagram. We're going to do some inheritance today. But before we do that, any questions? Yes? Yeah, that's a good question. So it kind of depends, right? If I'm sitting down and I'm just coding up a quick little example for something, probably not. It's a little overkill. If I'm designing a very large application with lots of moving parts, oh yeah, absolutely. You better believe I'm going to take the time to specify the design. If I'm doing something more small scale, I'll probably use techniques, or actually I might use this technique regardless of how big the application is. I might do some pseudocoding. That works very well on the small scale. It's a bit more, in the weeds, right? So pseudocode is great for listing step by step how you want things to happen. On a lower level, class diagrams are great on the higher level. If I'm just having a few classes, maybe not necessary, but for lots of classes, it's absolutely a must. And the nice thing about design is that any time you pour into design is actually time that you are taking away from having to code things up, because a lot of people will do design on the fly, which is actually just a polite way of saying they'll open up IntelliJ and start throwing stuff on the screen to see what works and what doesn't, right? So you're doing the design, whether you are conscious of that fact or not. You are doing the design at some point in time. My argument is if you take a little bit of time and do that design up front, you're going to save yourself some time when it comes to actually code. That's my personal experience. Whether that design is full-blown UML diagram or just sitting down and explaining the process on a sheet of paper using some illustrations, they're both useful. They're both good. But taking the time to do that is going to save you time when it actually comes to sit down to code. So we're going to make some diagrams. But before we do that, any other questions? Great questions today. Any other questions? Anything from the prep work that you were hoping I was going to talk about that I didn't get to, you want me to chat about for a bit? Okay. Well, if there aren't any questions, I want to make some diagrams, and to do that, I actually prefer to use a whiteboard or a piece of paper, but that's a little tricky with my current setup. So there's an online tool called draw.io that I like to use sometimes if I'm trying to do this on the computer, that allows me to make UML diagrams pretty easily and painlessly. So that's a tool that I recommend if you're looking for a digital tool. I really, though, would much rather have a whiteboard. That's my preferred medium for doing this kind of stuff. Today what I want to do is I want to actually refer back to this example that we did last week with the bank account. So the first thing I want to do is actually get this bank account as a design, put it in a UML diagram, and then I'm going to add some additional functionality to this, and we're going to design it and code it out with the time that we got left. So if I'm taking an existing class and converting it into UML, that's pretty straightforward. There's a script you can follow, right? First thing that we need to do is pull up a class, which is right here. Let's see if I can zoom in so we can see this. And the projector's fighting me as well. I'll try and do the best I can. Bank account. And so then I've got all of my fields, right? And so here we're really just copying private balance, private account number. This static field is a little interesting. So minus for private, we have, I just said them out loud and then promptly forgot them all. Balance and account number. Balance, which is a double. And I have to, oh boy, make some room for myself here. Account number, which is a int. And I don't believe the instructions or the prep work actually went into how to represent static things on here. And to be honest with you, I'm a little bit fuzzy on that myself. So static field UML. Let's see if there's a preferred way of doing it. Let's see, public, private, static. Underlining. All right, cool. If you underline it, then it's static. That's the information that I needed to know. It's still private. How do I underline? Oh no! Whoa! What happened? I'm not sure. Can I get a little more space here? This program is working real well for me today. All right. Get some more space. It underlined everything. Cool. Let's not do that. And all right, next account number, which is an int. And can I underline this without screwing anything up? Let's see. Nope. Awesome. Thank you for that. Come on. All right, I'm not gonna spend my time arguing with the computer. You're just gonna have to use your imaginations on that one. It's underlined, trust me, or don't. All right, and then the methods that we have. Notice that for the UML diagrams in the prep work, and I'm gonna follow the same process here, we typically don't list constructors on them. Do we need constructors? Yes, absolutely, right? That's something that we almost always need, but constructors are considered straightforward enough and ubiquitous enough that it's kind of redundant to put them on the diagram. So we'll just skip the constructors and do the actual methods. Also, simple methods like getters and setters, probably not going to show up on UML diagrams. So there's kind of a threshold, right, of importance to make it onto a UML diagram. Getters and setters don't make that cut. Constructors don't make the cut. Anything else, though, like with withdrawal and deposit, should absolutely make the cut. ToString probably doesn't make the cut, right? To get on there, probably just withdrawal and deposit. So we're going to add the methods on there. Withdrawal. And notice that we're not putting, did I misspell that? Oh, I did. Notice that we're not putting the parameter names on here, just the types. And then the return value is what goes over here, Boolean, which is too big for the box. We'll fix that in a second. And I need to make room for one more here. Deposit, double. Also returns a Boolean. And can I make this whole box a little bit wider so we can see it all? A little bit more. All right, that might be a little too big, but there we go. Here is our UML class diagram for the bank account class that we made last week. It was very straightforward for me to do. It didn't require a whole lot of explanation. It was mostly just copying information over. In practice, a lot of times you'll probably be doing the opposite direction. I'm going to take a UML diagram and turn it into code, not taking code and turning it into a UML diagram. That's what we're going to do next. Does anybody have any questions about this piece, though, before we do a little bit more work? Something a little more interesting? Yes? Yeah, what's the plus and minuses for? Does anybody remember? Public and private. So my fields are private and my methods are public, which matches what's in the code that I've got. Good question. Any other questions before we do a little bit more work? So this example of a bank account, it worked fine for what we were doing last week, but it's actually not a very good representation of how the world works, in my opinion. If I go down to Commerce and I say, I want to open a bank account, they're going to look at me and they're like, all right, what kind? Right? I can't just say, give me one generic bank account, please. They'll ask me what kind of bank account I want. And so in the most simplest sense, the choices that we have are, we've got like a checking account, savings account. There are lots of other types of accounts, but just to keep things simple today, let's focus on those two, checking account, savings account, right? There are some things that those accounts have in common, correct? There are some things that those accounts are, share. There are some things that make those accounts different from each other. And so if you're thinking about things in terms of inheritance and thinking about things in terms of what should go in the base class versus what should go in the subclass or the child class, the stuff that's in common to all of the classes is going to go where? The base class. The stuff that I want to be shared, the stuff that I want to be distributed out is going to go in the base class. The stuff then that is unique is going to go in each of the individual subclasses. That's the general pattern that we expect to see with inheritance. So let's create some more classes for checking and savings accounts and talk about what makes them unique and what makes them different. And I hope that it's very much clear, I'll say it anyway though, that I am not a banker, so the actual workings of banks are Not something that I'm super familiar with outside of having a bank account myself. That's about the extent of my knowledge, but we can still have some discussions about what makes these things similar and what makes them different. So first things first, we need to think about the fields, right? The fields that each of these might have. And so for a checking account, do I expect it to have these fields that I see with a bank account? I mean, are any of these fields not? Are there any of these fields that we don't want a checking account to have? I see people shaking their head no. That's a good sign, right? That's actually a good sign. If there were any fields here that we did not want a checking account to have, then we kind of have a problem because inheritance is going to give me all of them. Whether I want them all or not, I get them all, right? Or I can mark them, I can consider marking them with the different access modifier if I want to, I suppose, right? So the fact that checking account wants to share these indicates that, at least for our purposes, bank account has the right information in it. The shared data is in the right place. And the same question for a savings account. Do I want any of these, or are there any of these fields that I don't want a savings account to have? I think sharing these fields with savings account is also appropriate. So then what makes them unique? What fields does a checking account need to have that a base class bank account would not have? That's kind of the more interesting question here. And just to keep things very, very, very simple, let's, for the purposes of this example, say that a checking account, you have to pay a fee, right, to keep open, a monthly fee. I know a lot of places offer free checking these days, et cetera, but there certainly was a time when you had to pay a monthly fee to keep your checking account open. So a checking account needs a fee, and that fee is going to be deducted from your account. And so I think that's an argument for a field, right? Checking account's going to have a fee amount. What's the price that I need to keep this account open? I'll mark it private like all fields, and the type's probably going to be a double. And then what makes a savings account different from a bank account, right? What are the differences there? Well, a savings account, believe it or not, because it doesn't feel very true anymore, but it is, they accrue interest. They give you interest. The interest rate is like 0.25% or something ridiculous these days, but it's still there. It still exists. Theoretically, it could be more than that. They just, whatever. Not the time. So savings accounts accrue interest. I gain interest based on money off of that account. That's not true of a checking account, right? I don't get any interest from keeping my stuff in a checking account, right? So the value that I might want to keep track of for a savings account might be an interest rate. Oops. Which is also probably going to be a double. Notice that I didn't bother copying balance and account number and everything because once I get my diagram set up, I will indicate that I'm going to inherit those fields. So I don't need to duplicate them. It's not necessary for me to do. In fact, we can do that now. We said the relationship for inheritance is an arrow, which is one of these. Relation, message. Oh, well, is it in general? Yeah, this will work. We can just drop this here. We can drop this like so. Hopefully nobody is surprised that I'm doing this. I think this was, kind of the goal from the beginning was to have an inheritance relationship between these two accounts. So I'm going to inherit the balance account number and next account number, right, automatically. I've got the fee and the interest rate, which are my new things. And then in terms of methods, what behaviors do I expect these types of accounts to have? So for a checking account, I need to take the fee out, right? I need to get charge the fee, charge fee, and then for a savings account, what would the return type of this be? So we're actually making these decisions up front now, right? What would the return type of this be? I don't know. You could do a Boolean like we did for deposit and withdrawal. Maybe they don't have enough money for the fee. Actually, that's not going to stop the bank, right? The bank will take that money even if you don't have it. They'll just make you pay them back later. Maybe it should just be void. That's an option as well, right? For a savings account, what do we need to do? We need to compound interest. We need to compute what the interest is and put it back into the account, right? And you could make all sorts of arguments about other fields and other methods that you could put in these classes, other types of bank accounts that you can make, right? I agree entirely with all of those. I'm just trying to keep things simple for today for the purposes of this example. Does anybody have any huge negative feelings or want to argue against any of the design choices that I've made for this simple example? I'm certainly open. If you're very angry about any of this stuff, we can have a chat about it. And so the nice thing now is I have a design and I want to implement this design. It makes it very easy for me to do so. I know exactly what fields I need to make. I know exactly what methods I need to make. I don't know how those methods work exactly. That's still up to me to figure out how those methods actually work, right? But I have a blueprint that I can follow. Much like an architect has a blueprint for their building that they're constructing, I have a blueprint for my program now that I can use to, at the very least, set up the structure and then go back and fill in how everything's actually supposed to work. So let's do that. Let's start with our checking account, and let's go make a checking account that follows this blueprint. So here's my bank account from last class. I don't remember if I actually posted that. I think maybe I didn't, but I will post all 3 of these after class today. That's not a problem. Checking account. How do I indicate that I want this to use inheritance? How do I say that in my code? So our design says that a checking account inherits from bank account. How do I say that in my code? Extends. So up here I'll say extends bank account. And by doing that, just by doing that, okay, you can see it's a little upset with me. We'll take care of that in a second. Just by doing that, we have now inherited everything from the bank account class. You can see it's a little unhappy with me. It says there's no default constructor available. We'll fix that. Actually, what that error message is a little bit misleading. What this error message is upset about is we haven't created a constructor for this class yet. So the error message made it sound like I needed to go back to the bank account class and do something. And we maybe could have done that and made this error go away. But we can also make this error go away by just making a constructor here, which is something that we need to do anyway. I need to make a constructor here. So let's do that next. Checking account. And actually, before we can do that, we need to put in the field that I have mentioned here, the fee. So I'll add that field up top. Double fee. How do I get this field into the class? Am I just going to hard code it in, or should I take it in as the parameter of the constructor? Does anybody have any strong feelings? What should I do? Or we actually have another issue to contend with here, I think, right? A checking account has not just a fee, it also has a balance and an account number that it needs to set. Remember, it's still responsible for setting all of those fields, including the one that it inherited, right? So what parameters do I need for this constructor then? Do I need a balance? I think so. I'm still responsible for setting that field. I got to get that value from somewhere, right? I got to get this value from somewhere. Do I need an account number? That's a little trickier. We're not setting the account numbers, right? For our conversation from last week, we actually let those account numbers just be set automatically for us. So I'm not setting those account numbers. So we don't need an account number, but we probably do need the fee. And then the first thing that we need to do is make sure, or actually I should be asking you all, what's the first thing that you think I'm gonna push us towards doing next? I can knock out some of those fields right away by using code that we've already got. How do I refer to code that I've already got in my base class? Super. So first thing I want to do is actually call the constructor for the base class. So I'll say super, pass in the balance, and I believe that is a valid constructor. I can refer back to this to see that yes, indeed, I do have a constructor here that just requires a balance, and that takes care of balance and account number for me. So I've checked those off my list, right? The only one that's left for me to worry about is the fee, and we'll just set that the way that we normally would, using this. I want to make it very clear here that this constructor is doing its job. Every constructor has one job, which is to make sure that all of the fields get values. This constructor is doing that. By calling super, that takes care of balance and account number, and then setting the fee myself, that takes care of the last one. So this constructor is doing its job, making sure all fields have values. It's using the constructor from the base class to assist with that process. Does that make sense? I hope. Okay. Then the last part of our design that we need to implement is this charge fee, which should be pretty simple, pretty straightforward. It's a public method. We said it would be void, charge fee. And I need to simply take the fee away from the balance, right? So this dot balance is equal to this dot balance minus the fee. This dot fee. Seems pretty straightforward. I don't know if you all can tell this or not because the projector is very bad today, but it's angry at me right now. This is actually red. I know it looks like a various shade of gray, but this is red. It's upset with me. What's the problem? Balance is private. Balance is marked as private. Private means very much private. I can only access it within that class. If I want to access it here, what do I need to do? I can call getBalance. That's one thing that I can do because I have a getBalance class or a getBalance method. So that's actually one solution. I can say getBalance. That solves my problem. Is there another way I could have solved that problem? I could call it as a withdrawal and plug the fee in. Anything else? There's another way. The word that rhymes with elected. Talking about it a second ago. Starts with a P. Ends with protected. Yes. Yes. All right. I can mark this as a protected field in the bank account class. That allows any classes that inherit from the bank account class to use this field. And the error is gone. I'm actually perfectly okay with the other options that were suggested to me though. Using getBalance I'm happy with. Using withdrawal is a little, I don't know. I think it's probably okay. Withdrawal though does check. The problem with withdrawal is that it checks to see that you have enough money, right? And like we were talking about before, bank doesn't care if you have enough money. My, checking account has gone into the red several times when I forget to move money into it, right?
Unless you want to associate a fee with it. Bring that in there and say.
I could. Well, so does the bank account have any idea that fees exist? Does this class know that we have fees? It does not. It does not. However, if I did want to have a withdrawal method that did know about fees, I could do that, right? I could put a withdrawal method here. What's that called? If I put a withdrawal method in here? Override. I can override the withdrawal method. I can put a withdrawal method in my checking account class that works here. And that can use fees, right? That's aware of the concept of fees and can treat fees accordingly if it wants to, right? So that's another possible option that we could use. And which of these options is the right one or the best one? Honestly, they're all good in their own way. They all have their disadvantages in their own way as well, right? By marking things as protected, I've exposed balance, not just to this class, but to all classes that inherit from bank account. Maybe that's too much. Maybe I don't want to expose it that much, right? In which case, using a method like get balance or overriding the withdraw method might be a better choice to limit the exposure of that variable. But regardless, let's say that I do use the protected keyword here, and that's the decision that I've landed on. That's what I want to do. I want to use the protected keyword, right? That's changed my design. In fact, this design is no longer accurate. This says that balance is private. That's not true. It's actually protected. And I don't think the prep work went into this, but just on the offhand that anybody happens to know, does anybody know how to mark this as a protected instead of a private field? A quick Google search would tell us. In fact, I'll be honest with you and tell you that I Googled this very thing this morning because I knew I was going to ask you this question. The answer is one of those guys, which is called these days it's called a hashtag, but when I was a kid it was called a pound sign. Whatever you want to call it is fine. That's how we mark a variable as being protected on our design. And so then our checking account class is done. We have our savings account class to worry about still, but now that we've done this once, I feel like, the savings account is probably going to go a little bit quicker because it uses very much of the same ideas that we use in our checking account class. So, and there is one other thing that I wanted to show you today as well. So I might run through this one just a little bit quickly. If I'm going too fast, please ask me to slow down and explain what I'm doing. But I'm gonna put in the, extends what? Hello, bank account. We're gonna have an interest rate. And then I'll make the constructor. It takes in the balance, calls the superclass constructor. Oh, it should also take in the interest rate. And then our design also says that it should have a method called compound interest that just adds the interest rate in. That is a void method. And it's just going to take the balance plus this dot balance. I don't know that I need the parentheses, but times this dot interest rate. Oops. That's not what I wanted. Did I do something? Oh, interest. Spelling is like totally not my strong suit. Thank you. I don't know if for me, I don't know if it's even a matter of interest. I could study it all day and still not get it right. So here is what our savings account class looks like. It's fairly simple. It's fairly straightforward. It uses the same concepts that our checking account class did, but it's different from a checking account. It has differences, and I can see those differences here. This is actually a good example of design, right? Design using inheritance should have a significant amount of stuff in the base class to be shared and distributed. The subclasses then, I would expect, would have relatively less code because they are already inheriting a big chunk of code from the base class, so they don't need as much code. That's actually good. That's less time that I have to spend writing code, fixing code, right? That's less chances for me to make errors in my code. All good things, all reasons to use inheritance. I do have one more thing. I know I'm almost out of time, but I have one more very important thing that I wanted to chat with you about. Before I do that, are there any questions about what we've done so far? So I wanted to show you an example of polymorphism. So in order to do that, I'm going to make one more class. And it's not on my UML design, although we could add it if we wanted to. I'm going to make a bank class, right? A bank is where all the bank accounts live, correct? So I'm going to make a bank class. And a bank class is going to have a what? Not just one bank account, but probably a lot of bank accounts. And actually, you could make an argument to me, well, Doug, it actually has checking accounts and savings accounts, right? My counter argument to you would be, well, those things both are bank accounts. So if I wanted to have one big pile of bank accounts, I could do that, right? And it would be okay, right? I could throw checking accounts into the bank account pile. I could throw savings accounts into the bank account pile. I could throw anything that inherits from bank account into that pile. That's an example of polymorphism. And so I guess the point I'm trying to make here is that I can make a array list of bank account. This is the base class. Right? This is the base class that I will inherit, or import, rather. And then I can do, I need a constructor. All the constructor is going to do is initialize my array list. And then I could do things like this, where I could say public void add savings account, double balance. And then I can also, I'll come back and fill that in a second, public void add checking account, double balance. And in both of these cases, right, I can track both a savings account and a checking account in this array list of bank accounts, because a checking account is a bank account, and I can refer to it as a bank account if I want to, right? Savings account is a bank account, and I can refer to it as a bank account if I want to, right? Those are both things that I can safely do. That's polymorphism in action. Let me show you an example. If I want to make a savings account, I'll make a new instance of savings account. New savings account balance. And then I will simply add this to my array list. What are you upset with me here? Oh, savings account needs a balance and an interest rate. Whoops. I gotta give you an interest rate as well, sorry. Interest rate is like that, I don't know. For a checking account, I can make a checking account, new checking account with a balance and a fee, which is like $5 a month is kind of a lot actually, but whatever. And then I can also add that account to this list. So I've got methods now to create a savings account and add it to my list of accounts, and a checking account and add it to my list of accounts. So if I'm looking at this array list of bank accounts and I pull one out, do I know if it's a checking account or a savings account? Is that something that I am aware of? Not necessarily. All I know about it is that it is a bank account. That's all that I know, that it is a bank account, because that is the type that I specified on the list. However, that information alone gets me access to a lot of stuff. That lets me do deposits, withdrawals, and anything else that I have in the bank account class, because I know those methods exist in that class. It does not let me deduct fees from checking accounts or compound interest on a savings account, because I do not know if these things are checking accounts or savings accounts. That's not something that I know from doing things this way. So you could argue that that's kind of a disadvantage, right, of grouping things together in this more general sense, is that I don't have access to that uniqueness. But if I wanted to do that, I could also have an array list of checking accounts or an array list of savings accounts if I want to keep them separated. The point I'm trying to make here is that I have the option. I have the option to do that. I can treat things as the type that they actually are, the savings account, or I can treat things as any of the base classes that they inherit from. And the computer's not going to stop me. That's polymorphism. That is polymorphism in action. It's a more complicated topic than I've had the time to do justice here. There's a lot more nuance involved with polymorphism than what I've had time to talk to you about. But does anybody have any questions about this tool or about this concept? Yes?
Who to go about creating a main class and creating an instance of your bank account array list, adding multiple savings accounts and checking accounts? Would it matter that the name of each instance always counts?
Yeah, that's a good question. It would not. No, it would not matter that this name was the same, because this name is basically evaporated at the end of the method every time. It's gone. They're all still in this array list, and so if I want to pull them back out of the array list, I'm not referring to them by name anymore. I'm referring to them by index at that point, by position. That's how I would access them properly. So this bank class is very far from complete. It would need a way to access particular accounts, probably by account number. But I could write a method that goes through all of the bank accounts and searches for specific things. Get me a list of all accounts that have a balance greater than $5,000. I can do all of that. And it doesn't matter to me whether they're checking accounts or savings accounts in that case, right? Just tell me what the balance is. That's something that I can get from a generic bank account. I don't need to know if it's a checking account or a savings account to answer that question. It gives me that flexibility.
Using like ID numbers, you could, I guess, like set certain ID numbers for checking accounts.
You could if you wanted to. I would argue that if you really needed to know whether something was a checking account or a savings account, and also too, think about how an actual bank would do it, right? They would probably have separate piles for checking accounts and separate piles for savings accounts. And that's not necessarily a bad design. I guess I'm trying to make a point here that this is something that I can do, right? Is this the right thing to do in this specific situation? Maybe not, but the option is there. And maybe your bank, is a little sloppy with the record keeping, and this is perfectly okay. Like, I don't know, right? That's a possibility. I kind of doubt it. Banks are usually very strict about that sort of thing, but the option is there. And there are situations in which this very clearly is a good design choice. This may not be one of them, perhaps. Any other questions about this topic? I know I've said this before, but I'll say it again. It's very important, polymorphism, very important topic. Very common thing to be asked about during the interview process. So I know it's a new topic to you. I know that the ins and outs of polymorphism are probably still kind of sinking in a little bit, and it'll take a little while. It took me a while to fully understand and see the value of this concept, but I'm telling you that it is very important. It will make things easier from a design perspective if you embrace it and fully understand what it can do, the power that it can do. And we really just kind of scratched the surface. But we'll see some more examples as we go along through the class. It won't be the last time that we have this chat. Did you have some stuff that you needed to?
Yeah, just quick before I start.
Okay, yeah, go